Okay, moving on to the second page. Number 7, we want to find the measure of angle D. So D is outside of the circle, and so the general formula was that you would take the big arc created by D minus the little arc created by D and divide it by 2, and that would be angle D. So based on this, we know that 8y minus y would be 7y divided by 2. Okay, that's one part of the puzzle, but now we have to find y. So if you look at this circle, all 3 sections of the circle have y in them. And we know that they should all add up to the whole circle, which is just going to be 360 degrees. So 8y plus 2y plus y is equal to 360, which means that 11y is equal to 360. So y is, I'm going to use my calculator to divide. 360 divided by 11 is 32.727 and so on. So now if I take that and I plug it in right up here, and I'm just going to even keep it on my calculator, I'm going to hit times 7, and I'm going to hit divided by 2, and that will tell me that it is, measure of angle D is 114.54 degrees. Alright, moving on to number 8, quadrilateral ABCD fits perfectly inside a circle. So I'm going to draw a circle. Quadrilateral just means 4 sides, 1, 2, 3, 4. A. And now, in terms of naming it, it doesn't matter which way I go to get to B, but if I choose this way to go to B, the next one has to be C and D. I can't cut across the figure. Now we know that angle A is 70 degrees, and we know angle B is 90 degrees. And they want to know angle C. And I think they just said angle C. Let me just check. Yeah, just angle C. Well, we had learned, you might try and solve this problem by yourself, and that's great if you do. But we had learned a little trick. We had learned that if this is 70 degrees, then this whole arc is 140. It's double it. Which means that the rest of the arc is the rest of the whole circle, and 360 minus 140 is 220. So the rest of the arc is 220, which makes angle C half of 220, or 110. A quick way to remember it, angle A and angle C, because they're opposite each other, they have to be supplementary. So angle A plus angle C have to equal 180, so that told us automatically that angle C was 110. Alright, so moving on to number 9. 9, 10, and 11. We've seen this kind of diagram before. We know that QS is perpendicular to PR, so they've got that little right angle. And everything you know about that kind of that radius being perpendicular to a chord is true. Specifically, it bisects that chord. It cuts that chord into 2 equal parts. So for the first problem, I'll use red. PR we know is 8, and I'm going to automatically go ahead, since that's PR, and I know it's cut into 2 parts, I'm going to label them each as 4. QT would be 3, so this part is 3, and they want to know QS. Well, QS looks a little bit strange, but QS is just a radius. And we have lots of radii here too. We also have QR, which is a radius. And so QS and QR are going to have the same measure. That's going to help us to think about QR as being a radius, because that gives us a right triangle. And specifically, we want the hypotenuse of that right triangle. It's opposite that from that 90-degree angle. So r squared is equal to 3 squared plus 4 squared, r squared being the radius. And so 3 squared is 9 and 4 squared is 16. That equals r squared. So r squared is equal to 25, which we know is 5. So that's QS. QS, which is just a radius, has the same measure as all the other radii, which is 5. All right, let's remark this diagram. So if you need to pause it and write that down, go ahead. I'm going to remark this diagram with new numbers. We still know that this is being bisected, and we know that QS is 13, which tells me that the radius is 13. So all radii are 13. I like jumping right here to this is 13. QT, they're telling me, is 5. And so now they're asking me for PT, which is really the same thing as RT, and I'm going to go ahead and use that one. So now we have another right triangle. We now know the hypotenuse is 13, and the legs are 5, and we don't know the other one, so I'm going to call it X. 13 squared is 169, equals 5 squared, which is 25, plus x squared. So if I take away 25 from both sides, I end up with x squared equals 144, and x equals 12. And that would be the value of PT, which would be 12. All right, next one. If PR is 12, let's go back. I'm going to erase everything again to look at what that looks like. If PR is 12, and we've already said that that's equal, that means each of these bottom parts is just 6. And QS is 10, which tells me, once again, that's a radius. The radius is 10. So I'm going to go ahead and fill in that this radius is 10. And QT, now that's what we're looking for. So still Pythagorean theorem. We've got 10 squared, that's the hypotenuse, is equal to 6 squared plus x squared. 10 squared is 100, is equal to 36 plus x squared. Subtract 36 and we get 64 is x squared, and x is just 8. All right, moving on to the bottom of the page. Specifically, we're looking at number 13. Okay, we want to solve for x. We learned that from one point to a circle, tangent lines, because we're told that these are tangent lines are actually equal. So 40 equals 3x plus 4. If I go ahead and solve for x here, which is what I'm trying to do for all these problems, I get 36 equals 3x, divide by 3, and I get x equals 12. Okay, perfect. Number 14 is kind of like the problems we looked at right above. We have a tangent line and a radius. Those will always form a right angle. And we know that x squared plus 12 squared will equal this whole side, which is x plus 8 squared. And we've done that several times at this point in time. So x squared plus 144 equals, now we have to FOIL this out like we did before, x plus 8 times x plus 8. It becomes x squared plus 16x plus 64. It's nice because the x squareds cancel. I'm going to bring my 64 over, and I get 144 minus 64 is just 80. Good. 80 is equal to 16x, and I can divide by 16. And I get that x equals 5. All right, just 2 more to go. All right, next one. We want to find the met length of x, and we said that from a point to a circle, tangents are equal, so these are both 3. And if this is 4, this is 4. So x is the whole side, which is 7. All right, last but not least, we have a right angle right here. And so, because it's a tangent and a radius, and we have 4 squared plus x squared equals, and this is also 4, we just didn't write it in there for you, 4 plus 8, which is 12 squared. 4 squared is 16, plus x squared equals 144. If I take 144 minus the 16, I get 128. And I would take the square root of 128. I believe that can be simplified by dividing it by 4 and even 16. 128 divided by 16. 128 divided by 16 is just 8, which means it can go even more. It can be divided by 32. 128 divided by 32. Oh, is 128 a perfect square? Square root of 128? No. Okay. So 128, if I divided it by 16, I have 8 left inside. So it would be 4 root 8, and 8 is divisible by 4. So I can take out 4 times 2. And so I take out another 2, and it becomes 8 root 2. 64 went into 128. Okay, just to remind you, I know it's not on the review sheet, but things that are on the review sheet that we haven't talked about, your review sheet, your test is from 9.1 to 9.5. So we need to know all the formulas for arcs and angles, and then also all the formulas for secant and tangent segments. and they are all in your packet. And good luck!